In this tutorial, we will explain the usage and settings of our formula component. We will need a scene, a 3D object sphere prefab, and a logic asset. As we have done in our Hello World tutorial, create a new folder in Assets folder and rename it to Formula Component Tutorial. Then, in Hierarchy panel, add 3D Object Sphere, reset its transform values in Inspector panel, and drag it to Project panel to make prefab. Then create a logic asset. Right-click in Project panel, create Wings Production Logic. Assign the logic blueprint to Sphere Prefab. After adding logic component, drag logic blueprint in its logic property field. Go in Logic Editor and right-click at Choose Formula Component. Enable components for every frame. After checking B every frame and B enable checkers, formula component is still red. How to add the formula and its parameters. Click in the middle of the formula component box. The formula window appears. Type something simple, like a plus b, and press OK. As you can see, our formula appears in the middle of the box. But there aren't any parameters inputs yet. There is a little red circle sign with an exclamation mark right from the formula. Go with the pointer over it. The tooltip tells us that it can't find a declaration for the a variable. Click on it. A menu appears. Choose a float. Input A appears. But the little red sign is still here. Go over it. The tooltip says that there is no declaration for the B variable. Click on it and choose B float. B input appears and the red sign disappears. Calculated output appears too. The component is fully set. Now add another component named Model Component, which we will use as a value holder. Right-click on Model Component title and add Float. Parameter name window appears. Type float1 and press OK. Then add float2 of float type. As we can see, there are our variable names with fields for assigning values in the Inspector panel. Let's add values 2 for float1, 3 for float2. Now let's assign values from the model component to the formula component input points by connecting float1 model component output point with A input point of the formula component, as well as float2 model component output point with B input point of the formula component. In the Inspector panel, Formula Component section, check Show Log Checker. It will enable printing calculated values in the console in runtime. Let's press play. Console prints a plus b equals 5. That's correct. Let's try something else with our float values. Let's change our formula to a plus b divided with a minus b. And play it. Yes, that's correct. It is minus 5. If you have added the same values as we did. Now let's try with conditions. Change divide with greater than and hit play. As you can see, our formula component treats conditions as well. It calculated true for us. Now, if we try to change variables to vector 3, what will happen? Remove a and b inputs with a right click on them and choose Remove Input Variable a or b accordingly. The red sign appears. Click on it and assign Unity Engine.Vector3 type on both a and b variables. After assigning the type to them, the red sign is still here. Go over it. It says that the operation greater than is not defined for types vector3 and vector3. That means that you can't use condition rules for two vectors. So we must change greater than if our variables are both of the vector3 type. Change greater than with minus sign and click OK. Everything is OK now. Add two more variables named vector1 and vector2 of type vector3 to our model component. Add values 1, 0, 2 for vector1, 2, 3, 0 for vector2. Let's hit play and see what would be the calculation. A plus b minus a minus b equals 460 is the correct vector calculation. Let's try Boolean. Change a and b variables with Boolean bool. Red sign appears. It says that the operation add is not defined for type Boolean, which means that we can't use arithmetic operators for Boolean operations. Let's make a simple Boolean formula. Write A or B and press OK. Add two more variables named bool1 and bool2 of type bool to our model component. Add values true or checked checker for bool1 and false or unchecked checker for bool2. Hit play. A true or B false should be true, and it is in the console. We can also use Unity Math F class, which is assigned automatically. Add a new formula component and in formula window add math f sinus a plus math f cosinus b. Declare values of type float for both a and b variables. Assign float1 and float2 model component to a and b inputs accordingly. Press play. It is working. As we use MathF Unity class, we can use our own class. First, we need to create a script which has a class with a static function or functions in it. You can see in the upper inspector panel a script that I've made for us. After we create the script, we will assign our class to our component in the following way. Right-click on Formula component and choose Add Custom Functional Type. The search window appears. Type My Custom Formulas as we named our script that way. Click on the My Custom Formulas under it. The Adding Functional Type window appears that tells us that type My Custom Formulas is added. Click OK. Now we need to change the formula for the component to use our formulas. As you can see in the upper inspector panel, class My Custom Formulas has 3 functions inside. The first one, named My Float Formula, you can name yours as you wish, is of type float, and it takes 2 float values and returns float sum of them. Now we can write our formula as follows. Go to Formula window and first type the name of our script class, My Custom Formulas, then add dot. Then add the name of the function that we will use. In our example, it is My Float Formula. Then add brackets, and inside of them, our 2 float variables named a and b, comma separated. Assign float1 and float2 values from model component to a and b inputs of formula component accordingly. Let's see what will happen when we hit play. My custom formulas dot my float formula from a and b equals 5 is printed in the console, and that's correct. It is time for you to try to use our formula component. Remove a and b inputs and use second and third function from My Custom Formulas class. One more thing which I almost forgot to mention in this tutorial is the Create Component from Design button in the right-click menu. This button is used for creating a blueprint of the component with its formula and inputs. If we click on it, the window Choose Save Folder will appear to choose where the blueprint should be saved. We can change the name as we wish. After saving it, we can use it in Logic Blueprint by simply dragging it to the Logic Editor window. May the Logic Forge be with you.